Want to nail engineering manager interviews at MAANG and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into MAANG. You could be next. To learn more, register for our free webinar.
Hello. How you doing?
Doing good. How are you?
Good. All right. I just noticed that you mentioned database domain.
Yeah,
No,
but
yeah.
I have an interview on Monday with Google. It's more about the senior engineer, senior suite. It's
Mhm.
about database and system design. Two interviews.
Okay, so that's different because here I see object modeling. So I don't know if you're interested in object modeling, meaning class diagram and classes, or you're more interested in system design.
Yeah, more on the database domain kind of system design.
Okay. Unfortunately, I don't have anything specific to databases, but we can make it work. The more important difference is if you want to do class object modeling or you want to do system design. That is the main difference.
Yeah, I checked. I don't think they're going to be asking about object oriented so much.
Okay, so let's do system design then.
Okay.
Okay. So something that they recommend is that you share your screen so that when you get the recording of the session, because this is being recorded, you have what you did for your future reference. If you share your screen, you'll get recorded.
Yeah.
Okay.
So
So then I can go ahead and describe what we're doing. I usually copy paste it, but because we're not working over a shared document, I'll just tell you instead. And to be honest, the question does allow for a database design. Let's see. So what we want to do today is design a music streaming service. You can think of it as like Spotify. Okay. The requirements are that the users should be able to listen to anything available in the catalog. We don't need to bother with recommendations. And the catalog is just a set of MP3 files, each file about 10 megabytes in size. Okay, I'll let you. Yeah. The assumptions are what we want to design for is we want to allow up to 10,000 concurrent users. We will have about 100 million songs in the catalog, and those will be from about 1 million artists. Okay. The files are encoded at 192 kilobits per second. Okay. Kilobits, not, so be careful with the capital. Yeah, it's bits, not bytes.
what does that mean, this encoding?
It means that 1 second of audio consumes 192 bits. It's an indicate, yeah.
Compression.
So it's related to that, but what it means is how much data do you need to read from the file to play 1 second of audio?
Yeah. I got the streaming and prefetching and like that. Well,
yeah, it's because it's a music streaming. If it were like just music downloading, it wouldn't matter. But that's the significance. Then the machines that you can use to implement this have a 1 gigabit network cards and 5 terabyte hard disks and 16 gigabytes of RAM. And the rest is up to you. Basically, how you want to design the system. If you want to focus on more on the database design, well, it's really relevant for this, because how you want to organize things so that the users can readily access the files, how is the API looking like, etc., etc.
Okay, all right. So we can start with the high level. I was thinking to go as some microservices. So you have. So is a catalog already done? It's or do we need to add more music also?
Good question. To make it simple, let's assume that's a static
Okay, all right.
catalog.
So so music stream, and then you have this account management for the users, some microservices, and then you can have a recommendation service, and then you can have analytics service. Are these the kind of services were you thinking of?
Well,
Maybe we can focus on this one.
Recommendation is explicitly a non-requirement. You don't need to worry about any of that. Basically, you want to design a system that allows users to listen to the music. That's it. That's the only thing you need to worry about.
Okay, so they know what they want to listen. While they're listening, how the flow happens.
Right. So you can imagine them going to some web interface or some app or something like that, and then they choose music. What do you need in the back end? How does the system look like? How do you organize the data? How you make it accessible? So on and so forth. It even the reason why I gave you the specs of the machines, because based on all of these requirements, it also means that how many machines are you going to need, which means that also informs how you organize the data, how you organize the database. Can you use a single instance? Can you use several instances? How does the schema of the database look like?
Right. So this is a read-heavy workload, and what I was thinking is that so we just look at the data model first, and then so you have the song ID, and then you have there's some properties of the song. So like such as artist, ratings, region, genre, location. If you want a pop song from Argentina, you have metadata here. Then you have the artist table. You have the artist ID, properties, and then you can have the list of songs that they have made. You could have it separate. You could have it in a normalized fashion. So you have the artist ID and the song IDs here, because you don't have to copy the properties again and again. Then you have the user ID. You have properties, and then you can have the user ID and the songs listened last 3 months. So you can have a list of that, and this can have a limit of like 1,000 song IDs. 1 million artists. Okay, so 100 million songs. Now if you actually look at the storage, you have 100 million into 10 MB. This is with no replication here. So the gigabyte 100. So this is mega into mega is terabytes, and so this is one petabyte. and plus there will be more storage. So if you have, did you say 1 million artists? So if you have, this is for the songs, then this is for the artist. All this will be less than 1 petabyte. So if you have 1 million into 1K, this is all metadata. So this is like 1 GB. And then properties for the artist, like name, location, things like that. And now for the users, if you have 10,000 concurrent users, let's say 1% are concurrent, and so you have into actually 100. So let's say you have 1 million users, but I mean that looks very low. So if you have 100 million songs, you could have, let's say, 10 million users, or you can say 100 million users. But so even that into 1K, that table is not much. So it is like 10 GB. So we can have a different kind of storage for the songs. You can have one kind of storage for the metadata. Now I'm assuming you can have different membership types that that you can watch different songs, what you paid for. But let's assume that when you there'll be some other thing called a search service, searching for songs. But I don't know if you want that. Did you want that?
So it sounds interesting. Let's talk about it.
Okay.
Because you touched on a good point. The difference between the metadata and the data itself.
Yeah. So
go ahead.
So yeah. So in terms of the exploration service, you can actually this is very similar to Netflix. They divide people into lots of groups. But so assuming based on the user properties, you can actually show and you can ask them when they actually register during the user registration. They can create a profile about their interest, and kind of the genre, or if they like particular artist or location, and then you can actually show them those things. So within and when people watch, so there's also something called a watch history. So it's basically user ID, and I think we had that somewhere. I think so that you already had here. It's watch history. And so what you can do is we can actually group the top songs. You can group the top songs by region ID, like whether it's in the US or Asia or all those things, and then and the type and the artist. And so in absence of them specifying any interest, if they just registered without giving any interest, at least from where they registered, you can find the top songs watched, like the top, say, 50 songs watched in that region. So if you're in California, you get the top 50 songs, and then you can prompt the system, is it useful? Can you give more hints about your interest? And then you can ask them to see top songs, like in a finer detail. So that would how the search thing would actually be. So this is at a high level service. So you basically have two kinds of users who have given the interest, and then who not specified any interest. And these interests can be updated. So these interests would be actually here. So when you have this user ID and properties, you can actually specify the interest. Now in terms of the storage, so the thing is that we do need to scale, because the storage is very high. Commodity machines, vertical scaling is very expensive, so you have to do horizontal. Now if you actually have I think you mentioned something about 5 terabyte disks. So you have So in terms of the data, so let's say you do 3-way replication. So you have 3 petabytes divided by 5 terabytes. So this is how many machines you would need. And so you would have, this is 5, right? So 200 into 3. So 600 machines you would need, storage machines. And you can actually have, so you can divide this into shards. I would actually shard. I don't know how important is actually region, because music, one thing to understand about music is that music is global. It's global.
Yeah.
And so people in US can have tastes about Mediterranean music also. So I would actually, it's important. So we have 2 options. You can either shard, you have to shard, otherwise everything doesn't fit on one place. And if you go through the same network cards and all that, you bottleneck. So you have to spread it over different storage and maybe data centers also, and also you want geolocation. I'm assuming the users are all around the world, or they are like probably in one state.
Yeah, all around.
It's okay. So you need geo. So the sharding can be used in 3 ways, and you can do sub-sharding and sub-partitioning also. So you can shard per region, and we were discussing, this may not be very useful. You can shard by genre. I don't know if people actually, how often people look. I think this is important. If they want to listen to romantic songs or pop songs or like that. And the thing about it is, few people know that they actually like certain artists. So you can actually you can actually subshard by artists. If the number of queries on artists are high, you could actually you can copy the metadata. It's like that metrics thing, whether you want to shard by server ID or the metric ID, and you can actually copy the table and you can shard both ways. So you can make queries on metric ID also fast along with server ID. So assuming right now, if you're sharding by genre, then so if you have 600 machines, and then and suppose there are 10 types here, let's say, and so you would actually so it's basically 200 shards into 3, right? And so you would have on each shard, so you let's say if this was uniform, you would have say 20 shards per genre. I'm not talking about replication right now. So 20 shards per genre, and so if you have shard 1 to 20 for say pop music, right? And so there you would actually you can actually subshard by artist. So this is artist A to B, and then shard 2 is artist with a first name, last name C, like that, and last name Z. So this is one way to shard the thing. So this is you use this as a sharding key, and this is a subshard.
One question: how are you actually implementing the sharding? So I understand that you're talking about it in abstract terms, but how would you implement it? What kind of database, what kind of backend would you use to implement it, and how would you implement the sharding?
Yeah. So relational database is good for OLTP, and so if you have if you look at the amount of storage for the artists, the users, and even the watch history, like, so if you look at the watch history, so let's say you listen to 100 songs. It's if you have say 10 million users. So what do we take, 100 million users or 10 million? Let's say take 100 million users, and then so into say 1K, which is gigs. So this is 100 gigs. So it's the storage can all fit here. So if you have metadata table, and the whole metadata table for the artist and the song, for these properties. And I think how many songs did you say? 100 million songs. And so let's say, so for the song table, if you have also say 100 million songs into 1K for the properties of the song, so that is also like 100 gigs. So all this can actually fit into storage. And then we'll talk about caching also. The other thing is also, I was thinking about chunkify the songs of 10 MB. So if some songs are very popular, if you split them across the cache servers, then you can reduce the hotspots. This is typically done for video files, which are actually in gigs. But we can consider if this is important for music streaming. It may not be the very most important priority. But the main thing is that when you come through the cluster manager, so you have the like a zookeeper, and so you have the load balancers, and the users are coming here. So they are in different geography. So if you have like let's say 10 data centers worldwide, then that way they will go to that the cluster, and then from here you can go to the app server, and here you can just round robin. That's one way of doing it, because it's mostly a stateless. Any user can ask any music. Then you can have another config store and a cluster manager, which will actually go through they want a song ID. At the end of the day, the main thing, okay, they went through the search interface, then they want to play a song. And so when you actually come here through the load balancers, you actually, there are cache servers. And you can actually, this cache servers, so what we talked was, inside these app servers, you can actually store the artist information, right? You can actually store even the song information, right? You can store this in memory of the app server, because I think you mentioned 100 million
songs.
100 million songs, 1 million artists. And if you want information about the artist, so it's 1 million into 1K, which is 1 GB. And so you said 16 GB RAM, so that fits in there. And if you have 100 million songs, and the song information is it's like 1K. So what did we say? 100 million into 1K is 100 gigs. So 100 gigs is not going to fit in one RAM, right? And so what we can do is that you can actually go to the cache server, where you can have multiple cache servers where you can fit in the song metadata. And you can also fit like, so if the song information is 100 GB, so let's say you put 20% in cache, that's 20 GB. And if you have across two cache servers where you actually shard the song ID, then the entire song metadata can fit in just a few cache servers. So in every region around the world, you can actually put the metadata of the songs and the artists out there. So right now we're not talking about recommendation systems, right? So in which case you would have to put watch history and some other things also. So now if you come to the storage servers, so you have the config store, and then you have the cluster manager. So you have the storage servers. And so the thing is, what we talked about was you actually hashing the song ID, right? From the song ID, basically this is hashed per genre, and then subshard per artist. And so you can actually find, so from this, so what you do is you do a hash of, so from the song ID, you can actually get the genre and the artist name. Okay. And because there's, I don't know if it makes any sense just to do a song ID is pretty much an arbitrary number, and then you can do artist name. There's another way to do this. This song ID, we can actually do how these time clocks work. So what you do is you put the first few bits as a genre, then you can have region ID, and then you have the artist ID. Okay. So when a song is selected, you can basically do this hash and find which shard it's going to go to.
What
Now,
if the song? So this assumes that there's a one-to-one mapping between song and genre, but a song can have many genres.
It can. I mean, typically I've seen. What is an example?
So for instance, you can have Rolling Stones and it's rock, and it's also, I don't know, 80s and things like that, or metal,
Yes.
like metal,
Right.
heavy metal, etc. There's like a song. It's one to one from song to genre.
Yeah. So
But that's fine. Let's not get lost in the details. Let's you somehow come up with a song ID that's a number, and there's many ways to achieve that.
yeah, and so yeah, you can go into the top of the 80s, 90s favorites, and then okay, if you have a, I mean, you could have a genre like, and I don't know if you want to have a subgenre, but for example, this is the time, and then this is the category. So if you say hit of the 80s, but then there's no subgenre. But anyway, so let's say you have this genre. So then you actually go to the chart. Then you have this consistent hash. So suppose you have 3 charts. And this is a very simple example. 1, 2, and 3 charts. They can actually map to different storage servers. As the storage servers come up and go, then the config manager will actually get the shard ID, and then it'll give you a particular server. So you'll go to a particular storage server who will actually get the thing. And then there's also replication. So you can have so this is mostly like a keyword value store. So this store that we are talking here for the songs, that it's static. So you don't need this to be like a relational OLTP kind of thing. It is just like an object store. It's like a blob store. And things are just stored, and I'm assuming that each song needs to be stored only in one encoding. Now, how much storage to get? Because I think there was a hint based on when you said encoding, and so the app server, the internal API is, you want a song ID, and you can basically say how many the seconds offset, and the app server actually knows the internet connection speed and how much of buffering you actually want to do. So suppose you want to buffer 5 seconds of songs. Like in movie, this is what happens when you're watching on your TV. It's actually buffering another few minutes of the movie, right? And so you can actually do this, and you don't have to. Okay, so let's say how big the songs are. Let's say the songs are, you said 10 megabytes, and let's say it's 200 kilobits a second. Kilobits a second, 192. So 192 by 8 is 8 12s are 96, 24 kilobytes, right? So if you have 24 kilobytes per second of song. Is that right? And so if you have 10 MB, so you have 40 seconds of song. 24 kilobytes, another 400 seconds, I think. So you have 24.
Yeah.
Okay, 400
Yeah.
seconds. 400 seconds is like around 6 minutes of the song, right?
Yeah.
Each song. Okay. So you are basically the app server will drive how much buffering, because you can be in different places in the world and where the internet connection is good to weak or whatever. And so in some cases it may do less buffering and more buffering, but that logic is driven by the app server. An app server will basically tell you the seconds offset from actually where to read the song. If it's in the cache server, it will get it. Otherwise, the cache server. So now each song ID. Let's say you have 5 seconds. So 20 chunks a minute into 6. So if you have 120 chunks of the song, and so you have in the cache server, you have a hash map where you can have the song ID, comma chunk ID. And if the request, so because you have lots of concurrent users, you mentioned, right? 10,000 concurrent users, and and so you have these lists of the hash map, right? You could have different hash maps. Again, it's just like the buffer cache design inside the database. You can have multiple buffer pools. So you can have multiple hash maps. You can have hash maps for genre. And then you can have within that, so it's like a hash map of hash maps. And once you actually get to the right hash map, then I don't think you need one hash map per song, because they're like, did you say 100 million songs? So
yeah.
And in the cache, so how many songs can you fit in one cache? So you said 128 GB. So if it's 128 GB, let's say you're taking a percentage of the memory, right? So let's say 100, because you need for other things for the OS and all that. So let's say you take 100 GB memory and then divide by 10 megabytes. So how many songs can fit in here? So you can have 1,000 into 1,000, right? So you can have 1 million songs that can fit inside one cache server, right? And so this based on the song ID, this second cluster manager, right? So this is a cluster manager 1, cluster manager 2, cluster manager 3. The second cluster manager can route you to the cache server, which has those songs, comma chunks. Now, and let's assume we are looking at it at a whole song level, which is 10 megabyte level. Then you just have to route it to where the song is. But if you're going to do this chunkification, then you can have so if you have the song ID, it's a hash map. So if you just have the hash map of song ID into the pointer in the cache, okay. And so if you don't have chunk IDs, so it's just a hash map of song IDs, and then and you can have hash maps. So I would say it's a hash map of genre to song ID. So you have one hash map per genre, I would say, like this. And if you mapping to multiple genres, you can take any hash map. So if you're like, let's say 80s and pop, right? So you can pick any hash table. It should be there. That's one way of doing it. But because it's not the whole song, it's just a pointer into the cache. Right? And so when you're actually adding something to this, you lock the bucket. If you're not going to increase the hash table, you don't have to lock the whole hash table. It's just a bucket. And if you're just reading, you don't need to take any locks or latches, I would say, because there's not much of it's just a critical section. So latches, you don't need to latch the whole hash map. You just latch the bucket. So you in the cache you would have a hash map, okay, and then it's in a blob object store. That is what the database is. and key value store. So what do you think? Chunk IDs are required?
I think it's an interesting idea, but it probably overcomplicates the design.
Right. So you can just remove this, and so you just have a hash map for the song ID. You'll get the song. Okay. And then but I was just wondering, when you mentioned, what was the value of this requirement, this encoding 24 kilobytes per second? Are you
So if there's something that, because you have been focusing on the data schema, the data model, and we haven't touched upon it because you wanted to focus on the database, but because it's a streaming service, that's the same reason why I mentioned the network cards. You can imagine there are bandwidth requirements as well.
Yeah.
That's the reason when
Right,
you have to go down to the bandwidth management.
Yeah. So yeah, because you're streaming data, correct?
Yeah.
And so I did something about this cache. I thought it was 128 GB cache, but since you have 16 GB cache, you'll have to adjust it. This is what I thought. 128. It looks like you have a smaller memory, so you'll have to adjust this. So let's say you take 10 GB, so you have 0.1 million songs. Okay.
Mm-hmm.
And so in terms of the network bandwidth, now just think about this. If you have 10K concurrent users, right, and they are streaming one song each, right, at a time, so that's 10 megabytes. So how much is this? 10K into 10 megabytes, and so that is 100 GB, right? There's a bandwidth requirement. Assuming everything is in the same data center, but if you've divided up to 10 data centers, can we assume how many data centers you have?
You can have as many as you want. But so the thing with the bandwidth is you gotta. So for instance, can you serve all the 10,000 concurrent users from a single node, or how many? Like what are the constraints introduced by the bandwidth? But as far as the machines go, you can place them whatever you want. You can have as many as you want.
Right. So if you have out here, so you need 100 GB bandwidth, right? If you are doing 10 songs, if you're not chunkifying, this is what you need. And so 1 second, I think you'll probably be streaming 1 second at a time. And so if it's when you're streaming,
Right, but there's a difference. What you calculated there was the download, but the download there is no dimension of time there. That you only calculated space. When you do streaming, you have to introduce the dimension of time, and then you can, yeah.
So if you're per second, you need 24 kilobytes, right? And so okay, so this is megabytes, 240 megabytes. It's 240 megabytes per second. And your network card, right? The network card is 1 GB. So can we assume that everything can fit on one machine's network card in this case?
So you be careful with the units because the network card is 1 gigabit per second.
Yeah, bits per second, right? Okay. And then so okay, so 1 gigabits per second, right? And so you divide that, so that's
25, I think.
Yeah, 120 megabits per second is a network card. Okay, so it looks like it's 120 megabytes per second, right? And so we need at least 2 network cards. And then So if you're actually having two cache servers, like in the simplest case, if you have two cache servers, then you could satisfy 10K concurrent users.
Mm-hmm.
Is that what you were looking for? But I mean, there can be some other hotspots, because in terms of data structures, latching, and
Absolutely.
CPU and threading and all that, and so just looking at the bandwidth of the data card, it gives you the minimum amount of nodes you need, but you in reality, to get some good quality service, you it would be good to calculate. Let's say everything is in one data center, right?
Mm-hmm.
Then so how many cache servers you need? We were looking at how many shards here, right? And so 200 shard, if you actually that is for the storage, and you could map a different number of cache servers to the storage, but you cannot fit all the songs inside memory anyway, right? And so because you cannot fit on the disk also, you need 200 machines for the storage. And so if you actually if you look at it, so the data is 3 petabytes. So data is 1 petabyte, right? If you actually look at it, 3 petabytes is a replication. So if it's 1 petabyte data for all the songs, yes. And then so you could say 20% to 30% in cache, you're looking at a 300 terabyte cache, because typically for good performance, so 300 terabyte cache, and you said you have 16 GB. This looks like a small machine, 16 GB. But out of it, let's say if you have only 10 GB available of that machine, if you want to fit so many songs, you would actually need 1,000, million, 3 million cache servers.
Right, which probably, I mean, why do we need a cache? Is it justified that we need cache servers at all?
Yeah, the cache servers is the thing is that the latency for getting something from the RAM is from the disk is like 10 milliseconds, right? And so that's like 20 times RAM, even for an SSD, and it's much worse for an hard disk. But I don't think we are trying to optimize. It's not a race to optimize download speeds, right?
Exactly.
And so there may be some startup time, but because this is a human, it's not a server trying to listen to a song. It is a human trying to listen to a song. So once you start streaming, right, then maybe we don't need any caching. If you don't want to cache, do we want to cache anything, or do we don't want to cache anything? If you just want to stream, it's not clear if you need any cache. Once you start streaming, as long as you have the network card bandwidth, you go to the right shard, and then you will be able to. But I think you would need a buffering at the app server, right? In case there are some slowness or hiccups. So the app server is going to give the offset, isn't it, to the disk to say, I want to read from this second to this second now, and which this guy has to translate to kind of offset in the music. That is how the streaming would work.
Yeah. So ultimately, given that we are dealing with streaming data, and the encoding requires only 24 kilobytes per second, and because we're gonna need the limiting factor here is the storage. We need a bunch of machines, mostly because of the storage. Every other factor is not really a limiting one. Storage is the limiting factor. Then, because we have an oversupply of machines, there is an abundance of both hard disk bandwidth and network card bandwidth that renders the need for cache moot.
Yes. But
Then there's yeah, go ahead. Sorry.
No, that's fine. So, but you need buffering on the app server, right? To keep the quality of service, like you do buffering on the movies.
Yeah, but the question then, my argument there would be, can you rely on the operating system for that? Because it will happen already, automatically. So when you're reading
sorry, at the app server level, you have this app server, right, at the very beginning, which is providing you the search interface, right? Where you say click on the song, I want to listen to that. That app server interface, if you don't have cache and then you just have storage, yeah, and you said there's a lot of network bandwidth now because you have thousands of storage nodes. This guy will have to do some buffering.
What is it buffering, data or metadata?
It has to buffer data for the song, because on your mobile phone, when you're listening to Spotify, you have to buffer. If you're listening to second one, you should buffer another 5-10 seconds. And so you want to read ahead, like prefetch another 10-20 seconds in case there's some network hiccups. So that the experience is good. Yeah.
So there's a little burst at the beginning. So you can multiply by 3 or by 5 number of seconds that you want to buffer, and that is going to be a spike at the beginning. But then to keep that buffer populated, then it goes back to the standard 1 second every second. So basically, the head of the buffer advances at the same rate as a playback advances. So it's only at the beginning that you need a burst of bandwidth to satisfy that buffering.
Yeah, and different people are watching songs at different times. So at the storage level, you may not see a real burst.
One question. So you mentioned the app server serving the data. Are you saying that it would be a single machine, like acting like a proxy, and that machine, all the bytes of all the songs flow through this one machine? Is that what you're saying?
Okay. No, I didn't. Actually, what I meant was, if you look here, there's a load balancer, and so if you have 10 data centers, then you'll be routed to the nearest data center because of CDNs, right? Yeah. And so you would basically because if you're sitting in another continent, it's you don't need to unless some companies start like this. They only have one place in the whole world. That is how they start. And so then you would still go through a load balancer, and you can have multiple app servers. Otherwise, this is what we do. It's like a denial of service and crashes on the website.
For sure. But then the data itself, so a request comes, it hits one of these after the load balancer, then it gets load balanced into one of these
app servers.
And then ultimately, what is the role of the app server? Is it acting as a proxy, meaning that all the bytes for its domain, do they flow through the data server, or is it playing a role?
It's a good question. I think what you're referring to. Sorry, go ahead. What I was saying, you have a mobile, right? How does this start? You have a mobile phone.
Let's see the data flow.
And so this is where the app server can be. That is another way to, because the app is sitting here inside the mobile, and this guy can buffer 5 seconds plus. Wherever you are, another 5 seconds, it keeps on making sure it is there. This guy can go through a gateway, and this guy can be connected with but this gateway will have to I just needed an app server here to basically say that when you have a song ID to shard ID to the storage server, so you have to do this mapping. You have to know, and so you need to have this whole like cluster manager software which is sitting behind the gateway. You don't want to expose it for security reason here. So there may not be any buffering of data at the app server. It's like a pass through once you start streaming. Now, once you start streaming, you could directly connect this mobile app. Once you figure out which shard to go to, you could directly connect. Are you thinking this way? from the gateway directly to the storage server. So the app server is just an like a routing.
Makes sense. That's
So
what
I guess because the gateway may not be able to understand all that, right? Or you think put it inside the gateway logic itself?
No, this is what I was hoping for, basically, because if you make the app server a bottleneck, then bad things happen, and single point of failure, all those kinds of things. Whereas doing it this way is basically what I was hoping you would say.
Okay, cool. All right. So I think we talked about. So are there any other bottlenecks that we want to look into?
No. I think that was the main one. I wanted to make sure that I understood the role of the app server.
Yeah, it is just as a router. So it's like, in a relational database, you have like a connection pool manager. So once you get access to something, then that guy gets out of the way, right?
Yeah. This is similar to how you probably read the GFS, the Google File System classic paper from 2003. That's basically how it handles files. There's a master that orchestrates everything, and then it points you to the slave node that then you talk to directly to actually get the bytes of the file. It's the same.
No, I have actually not read that, but as we were talking, I realized that the role of the cache server and app servers are kind of getting less and less and less, because I think if you have to design a recommendation service, the app server would have a bigger role, right?
Yeah, because it has all the information about the which songs were preferred, and then it has the log.
And then if there is some machine learning logic running on the side, that you need an app server. And then so the search logic would be inside the mobile app. I mean or do you need the app server to help with the searching which song to play? So I think so just so the whole search logic would sit inside the mobile phone.
That's a good question. I think it's too big to sit in there.
Sorry?
So you said the search logic will live inside the mobile app?
The search, because app will have, whenever you have a mobile app, you have something called the app data, right? And then if you're on a PC also, you have the app data. So app data will tell you about the genres and those things. And it can actually pull the metadata from the storage also. And in fact, if you want, I think the app server can store the metadata. That might be a use of app server, where it can actually, based on your interest, it can maybe help you search better. Because otherwise the app data on the mobile may take a lot of memory.
That's my point. You cannot afford to have all the metadata on the phone at all. But of course, you can have a snapshot of it based on your activity, and then reach out to a metadata server to interact and refresh, get a different chunk of the metadata relevant to the specific user.
Yeah, so that's what you were. Yeah, so the app server would store as a metadata repository also.
Yeah.
And second is a router. Okay, so I think then we are kind of done, right?
Yeah. We have about 5 minutes, and I wanted to go over the feedback as the fun part.
Sure.
So that was nice. What I would say, you clearly know, you've clearly done this, and especially with playing with the numbers, a lot of people get tripped up with the conversions. You didn't at all. You didn't bat an eye, which was really nice. The architecture was good, and I would say that one of the issues I saw with it was that it was perhaps overly complex at the beginning. Then talking about it a little bit later, we trimmed it down a little bit, and I felt that perhaps wanting to make it almost production ready from the get-go was getting in the way of getting to a workable, simple infrastructure that addresses only the question asked as part of the interview. You know what I mean? We all have this this drive to design a production-ready service, but that sometimes gets in the way of a successful interview because then you get into overly complex details. It's a good problem to have because it's easier to make it simpler. You already know how to make it simpler, but it's a thing to keep in mind. Try not to answer a harder question than the question that was asked.
Okay.
Related to this is that it would help. I eventually saw the big picture, but it took me a little bit, and I think it helps to have a high-level script of what your strategy is going to be, like the main talking points. I know that you have to assemble this list as you also think about it yourself, but it's good to take a step back every once in a while, perhaps every 5 or every 10 minutes, take a step back and rehearse that list, or walk through the list with the interviewer so that he or she can be sure to be following your thinking, as opposed to trying to follow what it is essentially a work in progress in your mind. Make sense?
Yeah. So what is the role of the app server, cache server, storage server? You kind of decide that first.
Yeah. So what you wrote was nice, but it was like zoomed in. It's nice also to zoom out every 5-10 minutes and go over what is the big idea at the moment when you do it. And if you can then have some split the screen, have a left side of it where you have the high level architecture, and then perhaps on the right side of the screen you can do the zoom in and the diagrams that you did. But it's good to always take a step back and revisit where we're at in terms of the whole architecture, so that both you can think about it, both zoom in, zoom out, but also for the interviewer to follow along. Oh, okay. Yeah. I wrote down here that sometimes you spent some time talking about two details that were too specific, like the chunking, the load balancing, the cache servers, the config stores, cluster management. Those are really nice ones, but you kind of go on a tangent. And unless the interviewer asks you about those details, it's best to focus on the high-level picture and then zoom in once you have a complete high-level design. Because otherwise, you can talk about, I don't know, any of these things. You can talk about caching for hours. It's just a complex topic. So zooming in too much in a specific piece sometimes will prevent you from completing the architecture for the question.
Yeah, and do you think it's better to have a pen and paper? I've got some A3 size paper. I can have a document stand. You put the iPhone camera, because when you talk about left and right of the screen, this iPad is only so big. And if I use Google Docs, you suggest I cannot draw all these arrows and boxes very fast out there.
Oh no, this is great. What you did was great, but you have a point. Perhaps it's not big enough.
So instead of left and right, what we can do is we can do a page up and page down like that.
That's fine. That's fine. I'm just saying, reserve some space, perhaps at the top of the document, so that you can go back to it and just have a zoom out version of the whole thing.
And do we need to put all these data models? I guess that's important to know how much storage you need and like that.
That is important because we focused on the data model today because you wanted to focus on that, but you can basically take a question like this and focus on many other things. Like we could have focused on the network architecture because the bandwidth is also relevant for that. How much do the machines need to talk to each other? Is there going to be contention on the network, etc.? So it really depends on what exactly you're focusing. But again, it's nice to have a list of things at the top that says, based on what you're focusing on, what are your constraints, and how are those constraints going to inform the rest of the architecture and the design?
No, I got that. Yeah, good. So could you just say something about this network part? I haven't had much experience there.
Mm-hmm. Sure. In this, yeah. So the machines, imagine n number of machines sitting in a data center, and we've established that you cannot fit all the data in a single one or even in just 10 of them. You need several of them. Now, because of that, the data is distributed. It's like a distributed file system. How are you going to get hold of the one file that you want? Who holds it? Who knows how to address that file? A request comes in for a file with an ID that identifies the file. How do you know which of the machines in the cluster holds that file? Well, that's the addressing problem. Once you find that out, how are those bytes going to flow from the machine that hosts the file all the way out of the data center and to the client? And depending on on how you architect the network, you may have a busy network that gets in the way of those bytes flowing, or you can have a nice network that it's better structured. And there's like books and books written about network topology for these matters. In this case, because you need so many machines for the storage and the network cards are pretty beefy, it wouldn't be an issue. But it's nice to touch upon it. Because you can imagine that if you have a network where everybody listens to what everybody else is saying, is going to be really, really noisy. Whereas if you shard, like physically shard the machines that can listen to what other machines are saying, then you at least minimize the amount of like chatter that can be seen on the network. Make sense?
Yeah, the whole thing is sharded. The cache servers are separate. No, not the app servers are separate. The app server directly talking to the storage servers, right?
Nice.
Yeah.
But so mentioning those things and then arguing that you do that so that you can perhaps plan for future needs. You want to always have the argument that the bandwidth is sufficient for the current use case and future use cases, etc. But not only thinking about the storage, but also thinking about, can the bytes flow through the network within the shard? And if they don't, well, perhaps you need a finer sharding.
Yeah, so the thing is, the network, since you have hundreds of machines for storage, their network cards are fine. But since they all go through the app server, at that point you may have an issue, right?
Yes, exactly. So those kinds of considerations.
Yeah, so I don't know what you can do. You need to have more and more app servers, so that because depends. So the mobile phone will talk directly through the gateway to the storage server.
Yeah, that would be one way of doing it. Perhaps. I mean, there's many different approaches to this, but that would be one. Then there's downsides. For instance, then you'd have to allow the firewalls. How are your storage IP addresses, internal, external? It opens a whole set of problems. But that's the whole point, right? So that you mention it, you signal that you're aware of it, and then you can have a conversation about it. That is where the signal is where you actually convey a signal to the interviewer that all this stuff.
that the signals are important, especially in Google. And so maybe I can read about this GFS. That has some of this network flow thing.
Yeah, there is two really good papers for all of these things. One is the Amazon Dynamo paper. It's a database, a Dynamo database, and another one really relevant, like similar to this, is the GFS, the Google File System. It's a classic one from 2003, I believe. Because of what we talked about, it's essentially a distributed file system. A music streaming system is a file system that holds music files, but it's the same approach. Those two papers are super good, especially the Dynamo one.
Okay, so these are the papers in the conference proceedings when they published it.
Yeah.
Okay, all right. Because sometimes people just have their own website where they write about these.
No. These are serious papers. They are groundbreaking at the time, and then with citations and authors and abstract.
Okay, all right, cool. All right. So what rating you might give on this?
Oh, I think it was good. And the only caveats were the fact it was a little bit chaotic at the beginning, so it was a little difficult for me to follow, and that related to that you got a little bit lost in the woods with details. But it was good. It's clear that you know what you're talking about, and I think that if you manage to organize the things that you talk about in a way that is easier to follow, then you're golden.
Okay, I see. Okay, cool. Anything else you wanted to say?
No, that's it.
Oh, cool. Yeah, I'm reading about this some course on database just to refresh. For 20 years, I haven't interviewed at any place. This is my first going to the target, and so it's been so let's see how it goes.
It'll go well. I have no doubt.
Yeah, then they're focusing more on systems and not much of coding. So
Right.
that's it. And the other companies wanted coding, so I could not get any system design interviews there. So I had to come straight here
Yeah.
now.
Yeah.
Because coding was taking me more time to prep, so I kind of stopped those companies.
Yeah. No, it's fun. Just keep it simple, and don't overcomplicate it. Don't make your life harder than it needs to be, and simple and to the point, and you're good.
Yeah. So this is for level 7 and plus. So I'll probably be talking about my database experience inside the kernel, so that they can see what the use is. And then whenever they ask me questions, I don't know how I can bring my own experience into the problem, but I guess I don't know how that will flow. So maybe I think if you come straight to the solution, if they're happy with the solution, then you can talk about some of your projects you've done. So then they can see a different angle to your work.
Yeah, you can always try to steer the conversation towards your field of expertise. Like today, we kind of did that. We didn't talk so much about network topology or anything like that. We talked about the data model.
Yeah.
But there's always ways to do that. And I mean, ultimately, they probably want to hire you for your strong suits. So it's in their best interest to let you talk about those.
Okay, cool. Hey, thanks for taking the time.
Yeah, my pleasure.
Yeah.
All right.
Thank you. Yeah, thanks, David. Bye.
Bye.